let's take a look at the impact on the perimeter and area of changing a particular figure's dimensions and by various factors. So here I've got a nice little rectangle. It's a 7 by 2 rectangle. I want us to figure out the perimeter, I want us to figure out the area, and then I want to see how both of those things are impacted if we take both the length and the width and multiply them by 3, triple each. All right, so first of all, let's find just the original recipe, perimeter. That's just the sum of the lengths around, so 7 and 7 is 14, plus 2 and 2 is 4, so I get 18 centimeters, no problem. Area is length times width, which equals 14, and these are centimeters squared. Okay, no problem. Now, I'm going to explode this thing out by a factor of 3. So this length of 7 is now going to triple, and the length of 2 is going to triple. And so now, what are we looking at? Well, new. It's a whole new rectangle. Well, what's the perimeter going to be? Well, what used to be 7 is now 21. So I've got 21 and 21, that's 42, plus what used to be 2 is now 6. And so I've got 6 and 6, which is 12. And so now I see a total of 54. And so what was the impact? Well, the impact, notice, is what? How do I go from 18 to 54? Well, we tripled. So our perimeter has tripled as well. Our perimeter has tripled as well. What about area? A great guess would be that the area will triple as well. Let's see if that guess is correct or not. So I take this long length, which is now 21, multiply by the width of 6. And so I see 6 times 21, which equals 126 centimeters squared. And what do I see? How does that compare to 14? Well, this actually, the area has been increased by a factor of 9. And notice that 9 is 3 squared. Why is that? Well, because I have an extra factor of 3 here and an extra factor of 3 here. So when I multiply them, I should have an extra factor of 3 times 3, or 9. And that's exactly what we're seeing. So area is actually going to increase by the square of this multiple factors if we're changing both directions at once. Pretty cool and surprising. Let's try another example. So here I've got a circle B. It's got a diameter of 20, and therefore radius of 10. And what I want us to do is I want us to find the circumference, I want us to find the area, and then see how both those things change if we multiply the radius by a fifth. So look at a fifth of the radius. So shrink it down. So first of all, just let's figure out the current situation. So circumference equals 2 pi r, so that's 20 pi, and the units here are meters. And the area is going to be pi r squared, which is 100 pi m squared. Now, let's look for the new stuff. All right, so now what we're going to do is we're going to shrink the radius by multiplying it by a fifth. So now, when it used to be 10, now it's going to be merely 2. So the circumference is going to be 2 pi r, that's just 4 pi m. And what's the impact? Notice that the circumference actually drops by a multiple of 1/5 as well. 20 pi times a fifth is 4 pi. Great. What about area? Well, it's going to be pi r squared, and so that's going to be 4 pi meters squared, because the radius is 2. 2 squared is 4. And so what's the impact now? Well, the impact now is, you can see, how did I go from 100 pi to 4 pi? Well, that's by a factor of 1/25th, which is 1/5 squared. So once again, we see that by changing, in this case, the radius by a particular factor, the area is going to change by the square of that factor. So area changes by squares, and lengths change by the factors themselves. Really interesting, but it makes sense, because I've got r squared, and if I'm going to shrink it down by a fifth, that's a fifth times a fifth, that's 1/25th as a new factor for the area.